Hello everyone. So this is Nivedini Sendiselvan and I'm from team ASCII 4. I have Amos, Jibin and Rhythm as my other teammates here. So we all came up with the topic CPS AI Assistant. Basically, it's an enhancing course discovery and student support AI system developed by using RAG AI framework and vector database. So in this representation, we'll be talking about how we can leverage RAG AI framework and vector database to build an AI-powered assistant exclusively useful for CPS students. And we also believe that this approach will transform the way we interact with the information, making AI system more reliable, efficient, and context aware. Next slide, please. So you all be wondering why and how we came up with this project idea. In today's fast-moving world, time is everything absolutely, and we all expect to have instant answers in hand. Just imagine a world where students never have to wait for office hours or email replies to get crucial academic information. What if your advisor was available readily to answer your queries anytime and anywhere? That's exactly what we are building. We are extremely happy to introduce an AI system that's available 24/7 to help CPS students. Now let's talk about how and what we have done to accomplish it. First, we just explored RAG, that is Retrieval-Augmented Generation, and its diverse use cases. I'll just come shortly to explain what is RAG. But to brief it, it's just a cutting-edge trend that's going to shape the future world of AI. Next, to initialize, we just grabbed the entire CPS website for program information such as tuition fee, course structure of a program. Then we split up those collected information into chunks and stored it in a vector database in the form of vector embeddings. In the end, based on the user's input query, we just pull the relevant chunk from the database by performing vector similarity search. So here comes the part, what is RAG? RAG is just a powerful and popular AI framework, let's say pipeline, that ultimately aims to enhance the responses generated by LLMs. So it does this by incorporating relevant data retrieval mechanism from a knowledge database. In our case, it's just a vector database. And it add it as a context to the prompt and setting it to the LLM for generating more accurate response. This way, it allows LLM to ground its response in a more accurate and more concrete way that improves the quality and reliability of the response generated by the LLMs. And I would also like to add some advantages of using RAG over fine-tuning LLM mechanism. So just imagine you're preparing for an exam. Fine-tuning is literally like memorizing the entire textbook before the exam. So if the textbook gets updated or undergoes any modification, you have to just relearn everything from the scratch. Now, having a RAG is like having a Google or open source library in your hand during the exam. Instead of memorizing everything, you just have to look up the latest and most relevant answers we need. And this is the major advantages of using RAG over the fine-tuning LLM system. And we find that RAG is better than in many cases. It always allows us to have up-to-date data, saves times and cost, and it's more context aware, and it's a versatile system. Now my other teammate will take over to explain the flow we have followed in this project.
So thank you, Nivi. Now we will go forward to the tech step which we have followed for this project. First of all, we had the crawl for AI, which is basically a crawler library to scrap the data from the Northeastern web pages. Then we have used Python as a base language of our system. Then we have the Olama, which is the embedding vector system, in which uh, we had used the Llama 3.3. Then for the storing our scrap data, we had used this Supabase, where we had stored all the vector database. Then we have the GrabQ, which is the fast interface to connect the Llama 3.3 uh, based on the 70 billion vectors. And for the UI part, we have used the Streamlit, which gives a seamless and faster user experience. So our data flow is something like we have first of all scrap the data using scroll for AI, as I mentioned earlier. After scrapping the data, we process some data pre-processing part. Then we converted all the vectors into embedding using the Llama 3 model. After getting the embedding vectors, we split it into chunks, and after splitting it into chunks, we convert it into metadata to store it into the vector database named Superbase, as I mentioned earlier. So this was all about the data we had done. We had scrolled the data from the Northeastern web pages and finally stored into the Superbase vector as well. Then, after storing the data, uh, the user workflow will be like as the user inputs some queries, it will search for the vectors embedding into the Llama 3 model. It will generate and vectorize the embeddings to get the chunks of relevant data. After getting the relevant data, it will search into the vector database, and vector database will retrieve the chunk which is suitable for the uh, containing chunks. After getting the chunk of query, it will again go to the Llama 3, and it will generate the readable response, and finally user will able to get the response from it. Now we can go through that UI walkthrough. So once you launch the application, we'll be having two options, like two search mode, where you can specifically search for a program, or we can do a general search. So, uh, what is specific program specific search? So it's basically we are pulling out the relevant chunk for that specific program, and we are um, making we are altering the chunks based on the question. And general search, we are mainly using vector similarities from the question we have asked. So this approach is actually good for getting an accurate result from the AI. So yeah, so we can see from the slides how we are using how the program specific search will be look like. So here we will be selecting a uh, course that is Master of Professional Studies right now here, and we will be asking a question, and we'll be getting the response for that. And so for the general search, so we'll be just asking the question directly, and we'll be asking like comparing or uh, what is the use, what is the difference between two programs or something. So here, like we'll get a response like comparison, and we'll get the difference between each courses and what are the importance.
So the run command is to just type Streamlit and run. I'm gonna specify the Python package that is rag.py. I hit enter. It opens up a web browser in my local host, and this is the UI that we are presented with. We have two search mode, uh, obviously, and why we have two search modes is that we had several like overlapping between more courses, and it had some issues while doing the vector similarity search. So that we kept two parts or two search modes for accurate responses. Now the first part, I'm going ahead and select the first part. The first part uh, is the program specific search mode. You can select a program. So here we have all the programs that are available in CPS. I'm going to select my program, which is MPS in applied machine intelligence. So if you just select MPS also, it will always list the full name of the program, which is Masters of Professional Studies. We have multiple options like online, Boston, and Portland. I'm going to select Boston, where I am studying it. And I'm just going to enter a sample query, which would be like what are the, or maybe what is the course structure for the program. If I hit enter, it starts pulling the chunks and it will generate an accurate response based on the user's query. So you can see it lists all the general requirements, the experiential capstone project, the elective courses, and the concentrations, and what are the courses available for each concentration. So this is pretty good. Now I'll go back to start a new search. So there is a button for start new search on the top left part of the website. If you go ahead and I'll now select the general search part. So here you can ask anything about courses. You can compare, you can ask, like info about one course with respect to the other course. So for example, so as you've seen before, we have two modes for applied machine intelligence program. We have Boston and we have online as well. So I'm just gonna check a comparison between those two programs. So compare between MPS in applied machine intelligence, Boston and online. So it compares between two programs. Let's see what it has. Okay, it actually lists all the similarities. So we have some similarities, we have some differences. So basically this location matters. So the other program, the one in Boston is an on-campus thing and the other one is an online. So the F1 visa eligibility is for Boston program, it is with F1 visa eligible and the AMI online program is not. So you get all the information about two programs, and this is the overall UI. And let me go back to the slide where I can explain about the future enhancements for this program. Now we'll talk about the future enhancements for this program. So uh, at present, we are just fetching information from a single source, that is the vector DB, and we don't have any other sources. So the next step is to implement an agentic RAG where an AI agent will fetch in information from the available tools. So it can be a web search, it can be the retrieval process from the vector DB, or it can be something else. So adding more sources is better for accurate responses and reliable responses. So the second option that we're going to do in the future is to have a conversational memory, because as of now, as you all have seen before, the UI just have a single chat window and it won't store the history of the user's query for a better feedback or better response. So we didn't do this because if you concatenate the history also, it will have a bigger context length. And the plan that we're using is free for the Grok API, and it won't go through if you're like passing a very big context. And the third thing is expanded knowledge base. The existing DB will only have information related to the CPS programs, and we would like to add more info about the co-op thing and the like info about other infrastructures on the college, like the fitness centers and other recreational centers, and infos about that. So that would be a good thing to add. And the fourth part is the enhanced vector